Okay, so for those who didn't get to the video for day 2 yet, our goal here is we're starting with an equation. That equation is going to have some appearance. I don't know exactly what it will look like. Pretend that that equation looks like this, right here. Pretend that this is a graph of that equation. It's not, but just pretend. Pretend that we are trying to find the slope of our equation at A, right there. The way we find the slope at a point is we actually find a secant slope to the left. I think it's fun how the box moves with me. Check it out. You guys like that's stupid. Make a secant to the left. Make a secant to the right. And then what you do is you make those secants as short as you possibly can. You make them infinitesimal in length. That gives you this picture. And then you conclude the following. If I want to know the slope right here at A, well, I know the slope from A to C, and I know the slope from A to B. If I make those slopes infinitesimally short, it sure appears to me that the slope at A is going to be 10. That's how you're finding the slope at A, by using 2 secants. Okay, that process is very lengthy. Like to actually do that with this formula is going to take a long time. So for our class, we don't use that method. In college, they'll show you that method. They'll make you learn it. For AP Calculus, it's not required. They allow us to go right to the shortcuts, which there's a good job of showing all the handouts here. So the pink handout, that's the shortcuts. When we use the shortcuts, it's not going to feel like we are finding secant slopes. It's going to feel like we're doing just some sort of algebra. But in reality, we are finding 2 secant slopes, and we're making them very, very short, and then we're finding the tangent slope that sits in between. But it doesn't seem like we are, just have to trust me that we are. If you want to see the full process, you have to go online and do a little research. You can find it, but we just don't have to learn it for our class, so we won't. Questions so far? Okay, so keep in mind we're starting with an equation y. We are trying to find an equation for dy dx. dy dx does not mean derivative. I'm sorry, I said that wrong. D does not mean derivative. dy over dx is derivative. So all of this is derivative. The d just means difference. Look at the picture. Look at point A. Notice that between A and B, there's definitely a slight difference in the x-coordinates. Small difference in the x-coordinates. That's what dx stands for. That small difference between those 2 x-coordinates. dy is the small difference between the 2 y-coordinates. So that would be the up and down difference between those 2 y-coordinates. That's dy. We're trying to find dy divided by dx. That's the slope. Okay? Questions, curiosities, anything coming to mind, just feel free to speak right up. Cool? So what we do is we are ultimately trying to find an equation for dy dx. The way we use the rule sheet is we first apply what I call the derivative operator to that equation. So on your sheet, you need to make sure you have exactly the same notation that I have. So you're going to first write down the problem. You must write down the problem first, otherwise it's too easy to get lost. You write down the problem. Directly below that, you're going to apply the derivative operator to both sides of the equation. So I'm applying the derivative operator to both sides of the equation. Okay? Questions from anyone so far? So if you've seen the video, this should feel very familiar. If you haven't, this is your introduction to it. So, but you still need to go back and watch that other example just to make sure you're getting good at this. So, cool? Okay, next line. I need to help you get used to the fact that there are different ways to write this symbol. The red is one way, here in green is another way. Like that. You can use either method. I will use both so you get accustomed to seeing both, just in case on the AP test they decide to use one or the other, you don't know which one they're going to use. So, questions? Please.
Can we do y prime, or is that not?
A third symbol they'll use is y prime.
Okay.
4 points for Maddie. A fourth symbol they'll use is y prime of x. So I'll kind of use all of them just so you get used to it. When you're doing the writing, you can use any. You don't have to use all of them. But I just want to make sure if you see a test question and they've used one of these symbols, that doesn't, freak you out. You're like, what are they doing there? So it doesn't matter which symbol they're using, you're okay. So does that make sense?
Yeah.
Cool. Anybody else? All right, next line, green. The way the rules work is we've got the derivative operator of this mess here. So we've got to go find a rule that fits that situation. So let me copy one over from a previous example. We need what's called the E rule. It's on your sheet. Right there. So the way the rules work is you first have to find a rule that matches. Here's how I know the rule matches. Notice that here in red I've got, choose red, here in red I have d over dx. In the rule I have the same thing, d over dx. So that's a match. Above I've got e raised to the root of 4x squared plus 6. Here I have e to g of x. So all I have to do to get the rules to match is correctly identify what g is representing in this rule. So within this rule, g is representing the square root 4x squared minus 6. Questions? So as long as I can recognize that for my application of the rule, g of x has this value, the rule is an exact match. It has to be an exact match, otherwise you pick the wrong rule. Equal means, hey, you can make a replacement because they're the same thing. So what I'm going to do is I'm going to replace all of this, which is right here in the rule, with this. That's how I use the E rule. Questions from anyone? So now all I do is follow the rule and make the replacement. So I grab this, pull it out of the way a little bit. So in green, let's see, I need E. So this is going to equal E raised to the g of x. Here's g of x. Multiplied by d over dx of g. Here's g again. We have d over dx of g. Square root 4x squared minus 6. Like so. Questions? So that's how you apply the E rule. The good news is that once you know how to apply one rule, you actually know how to apply all the rules, or at least most of them. Because the rules are all not, well, I should say the top half of the sheet, the rules are typically applied all in the same way. So it's not like you have to learn each and every rule, you just learn how to apply a rule, then you just extend that to other rules. Questions so far? Please, Nick.
Can you go over that again?
You're fine. So I'm going to ask you just some questions as we go over it to make sure this will really stick in your head. Are you comfortable that right here we have d dx of e to just something?
So that's the problem, where the, like, d over dx, you just put the problem, like, in parentheses, or?
Let me, 4 points. You're asking a good question. I just got to circle back how I'm answering it. See if this helps. We start with this equation. What we're trying to figure out is we need a formula for how this y value changes compared to x values. So mathematically, the symbol that represents what we want is we want to find the infinitesimal change in that y value. I wrote it wrong, sorry. Scratch. Come on, Broom. We want to find the infinitesimal change in e to the, so we've got e to the square root of 4x squared minus 6. That's how we would calculate a y coordinate. We're trying to figure out how much will that y coordinate change when the x coordinate changes by just a tiny amount. So that's what that symbol means. Does that feel okay? Good, 4 more points. Unfortunately, with a calculator, we're done. Like, you feed that to a computer, it knows exactly what to do, done. But the AP test requires that 2/3 of your work be done without a calculator to prove that you really know it. So we need to modify this into something more useful. That's the purpose of the rules, is to get a new formula that can be useful without a calculator. So we apply the rule once. Like we notice that this situation is an exact match for the E rule. The E rule says, hey, if you use the E rule, I will give you part of the final result, and then I'll give you something else you still have to do. So this right here, this needs a click for everybody. That's done. Like, the final answer will contain that. Okay? We still have to do this part, but we are partway finished with really figuring out a more useful version of what we are seeking, which is this. I don't know if that helped at all. Okay. Anybody else? Cameron, please.
Are we just going to have to memorize all of these equations on the pink sheet, or like how are we going to?
So the rules of the AP test are no notes. So the answer is correct, yes. The good news is it looks intimidating today. If you use my notation, if you go line by line, if you stay with me, I've never had a single student ever do poorly because they couldn't memorize that. It just takes a little practice, right?
When you rewrote what the E rule equals in green there, at the very end on the top part where the D is, did you mean to put that in between the fraction, or isn't that supposed to be on the top? Do you see?
Let me write something else and see if this helps. So, I'm not sure if this is your question, not keep talking to me.
Okay.
I'm going to write in blue exactly the same thing as the green, just to show two different styles, because I think that's what Braden is talking about. It's back to Maddie's question, 2 more for Maddie. You've got to be able to recognize the different styles so you are prepared for however they decide to write a question. So the green and the blue are actually the same thing, just 2 different styles. Is that what you meant, Braden?
Yeah.
Perfect. 4 points is perfect. Anybody else? Okay, back to Nick. 2 more for Nick. So you should always speak up because I keep using your name all over the place. We have used the E rule. The E rule has revealed part of our final result. It's like the movie Inception, actually. We applied the DDX operator to all of this. The E rule gave us this result. This part is done. We still got to work out this part. So it's like a problem within the problem. Okay? Notice now that the derivative operator, the ddx, right here, the derivative operator is now operating on only a part of the original function. It's only operating on this part. Like inception, we're starting outward, we're moving our way in. Questions? Cool?
Wait,
Oh, please.
actually, never mind.
4 points for asking. Anybody else?
What's Inception?
What's Inception?
Yeah.
It's a movie. If you haven't seen it, don't worry about it. 4 points for Cameron. Just keep in mind that the way the derivative rules work is they start on the outside and they work their way inward. So now we need a new rule because the E rule doesn't fit anymore. This right here is not d over dx of e to some exponent. So we need a new rule. So remove this. When we pick a new rule, we pick a new g. So g is changing every time we pick a new rule. I need the square root rule. So I gotta go find it. Hold on. Probably on this sheet. There it is. So let's copy the square root rule. Notice how the square root rule is a perfect fit as long as we choose g of x correctly. In this case, g of x is now going to equal, again, g of x changes every time I use a new rule. So g of x is now simply 4x squared minus 6. Question? All you're doing, no, talk to me, Cameron, talk to me.
I don't really get out of that.
So all you're doing is you're trying to find a rule that matches what you see. So look at what we have written. We've written down d over dx, just like this rule says d over dx. The rule says square root of g. What we have is square root of 4x squared minus 6. So simply making a comparison, I can see that g of x must be, for the rule to work, g of x has to be 4x squared minus 6. Otherwise, the rule would not be a match. It's all about getting a rule to match what we have. Because the rules, one second, the rules are the way that we basically create a formula that is more useful. But it's ultimately going to be a formula for finding tangent slope. 4 points, but I don't know if I helped or not.
Okay, I think I just thought it was supposed to be square root over 4x squared minus 6. That's what I thought the g of x was supposed to be, but I realized that it's not that.
You're perfect. 4 points. Nick, please.
So to find the rule, you're just looking at the first part of the rule, right? Not like the second equal thing.
Outstanding.
That's what we're putting into our problem, right?
Outstanding. Outstanding. Everybody listen to what Nick just said. Look here. The way the rules always work, now keep in mind, equal really means these things are the same. So there's actually no reason why you couldn't write the rule the other way. There's nothing wrong with that. But for our class, the way the rule is always used is you are looking here to see what you have. So you're never really writing that. You're just looking for it. You find it by saying, okay, it's a match as long as I pick G correctly. Then you make a replacement because equal means these things are the same. So this gets taken away, this gets put in place. That's how the rules are used. Is that your question? 4 points. Okay, so I'm going to use the square root rule. So let's pull it down here so I can use it. Let's get rid of this. Right, let's fix that a little bit. So the next line, notice, this portion doesn't, this portion does not change. This part's the same, we're just copying it down. Don't use ditto marks. Ditto is like your way of telling me you really don't want to retake test number 2. Don't do that. Okay, so we got y prime. Oh, let's use another similarity. I said y prime of x, just so you get used to it. E to the square root, 4x squared minus 6. Now we do exactly what Nick said. 2 more for Nick. We make our replacement right here. So I write 1 over, I'm going to make sure these are multiplying, so just be careful here. Multiply 1 over 2 times square root of g then multiply by d over dx of g. Question? Okay, the process just keeps repeating itself. I need a new rule. I've got to have a rule that matches what I now have for d dx. Again, these parts are done. Like, we don't have to worry about that. That is done. We've got to worry about finding something to put in place of this. So, the next rule I use is actually one that is the easiest to memorize. It's the add-subtract rule. The rule simply says if I have d dx of 2 things being added or subtracted, or 3 things, or 4, or whatever, I can simply separate the d dx operators. So I can do this. Y prime of x equals e to the square root. So this is just copying. I fully confess that the first couple of homework assignments will feel tedious because it's a lot of writing. It's the only way I have found to get you to understand the process correctly and to get the formulas memorized is to go through that tedium. It's not unlike the fact that all of you who play sports know you have to do conditioning. It's just part of the deal. So here I'm going to have d of 4x squared over dx, subtract d of 6 over dx. Please make sure you recognize that on this line we had 1, 2, 3 factors being multiplied. Therefore, on the next line, we still have to have 3 factors being multiplied. That means we must have a set of parentheses here. So we still have 1, 2, 3 multiplying factors. Question? Yeah, please.
Do you have to put parentheses, or can you just put the multiplication sign?
Oh, awesome question. 4 points. You have to have parentheses. If you just have a dot, it would only indicate that this was being multiplied, not this. And it will lead to a mistake. Yeah, so make sure you do parentheses. 4
Wait,
points.
what rule did you use for that last one?
So from here to here, I didn't go grab a picture of it. It's on your pink sheet. It's the add-subtract rule. The rule is really simple, Braden. It just says, hey, you've got d dx of 2 or more things adding or subtracting, either way. You can now just separate the d dx's. Does that make sense?
Mm-hmm.
4 points, please.
You have to find another, like, g to the x for the add or subtract.
Oh, awesome. No. So if you look at the sheet, where's my picture of it? Right here. The sheet kind of has a top half and a bottom half. For the rules down through here, inverse tan, actually multiplying constant rule. No, my apologies. I didn't say that very well at all. Skip, back up. The add rule, to me, is easier just to think about than to try and look at what's written. So don't worry about F and G on the add rule. Just look at what you have and notice that I've got d dx of 2 terms added. Therefore, I can create d dx of each term. That's all. Does that help?
Yeah.
There we go. Please.
So on the top, like that, the equation before the last one, it says 4x squared minus 6. So why don't you do -6 for the t?
Oh, you could.
Oh, you could?
So if I because addition and subtraction are really the same thing.
Yeah.
So if I wanted, Maddie, I could have written plus
And then a -6.
d of -6.
Okay, and that won't change the answer?
Same thing.
Okay.
Mhm.
You put parentheses around that, but it says on the paper it's supposed to be a plus or a minus, and one of the parentheses make it a multiplication between the dx, the d, 4x
Right here?
squared. No, yeah, but in between, right there, isn't that supposed to be a plus or a minus?
Right here.
Yeah.
Gotcha. Now what you're mixing up is where I use the rule versus the problem itself. So look at the orange and make sure this makes sense for you. You have 3 factors being multiplied. 1, 2, 3. So the next line still has to be 3 things multiplied. All that changes is this thing here gets broken into 2.
Okay.
That's the add rule. The multiplication doesn't have anything to do with the add rule. That's your question?
Yeah, that
Fourth
makes
one.
sense.
Okay, running out of time again, as always. Because last year we always had 15 more minutes every day. Plus we didn't have hybrid and all that. But anyway, moving on. Okay, this part's done. This part here is done also. We got to work on that piece over there. Okay, there's another rule. It's called there's a bunch of them. It's called the multiplying constant rule. It's really simple also. Right here. So look at this rule, raise your hand until it makes sense. But don't worry about like looking at the paper so much. This is another really easy one. You've got d dx of a number times some function. The multiplying constant rule says you can pull out the number. That's it. So the next line, all I do is pull out the 4. d of 6 over dx. When you watch the video for day, I'm getting all the days mixed up myself, day 2, or Monday, there's an explanation as to why d of 6 becomes 0. D of any constant is always 0, because constants aren't changing. So this is going to become 0. Again, the video will help you understand that. This is going to become 4 times d of x squared. So the next line looks like this. Write everything down again. Oh, let's save some space. Let's put these two together. This times this, fractions multiply straight across. So this will look like this now. Should have done that sooner. Then I have parenthesis. I have 4 dx squared over dx plus 0. Like that. Question? Please.
Can you go over all that equals 0 again?
Uh-huh. So remember that d means infinitesimal difference. So when I write dx, I'm thinking of a graph where I choose 2 different x's that are close to each other. And I see how different they are. And I compare that to how different 2 y coordinates are. Well, with 6 it's different because 6 isn't changing, it's just always 6. So d of 6 is 0. Because I can't change 6, it's just always 6. So the difference between 2 6 values is like saying 6 compared to 6. That's always going to be 0. See, dx is different because dx is like comparing this to this. There is a difference there. It's very small, but there is a difference. But 6 compared to 6 is always 0. 4 points. Okay, we now have to use the power rule again because we have right here d dx of a g of x, which is just x, to an n, which is just 2. So, get something to work here, hold on. Sorry. The little thing I'm looking for is not present. We'll just have to squish it in. Pull this over here, pull this over here. Okay, the very last line. If you have d of x squared to 2, if you apply the power rule, I'm rushing because of time, you're going to bring down the 2, so you'll have 2. Then you have the g of x, which is just x. And then you're going to have 2 minus 1. 2 minus 1 is just 1, so that's just going to be 2x. So we're hurrying because of lack of time. So you need the pink. You need this. I'll talk to this.
Yeah. Whoa, you call, man. I'm just coming in to talk.
So this becomes this. And I did rush through that a bit, I apologize. 4 times 2 is 8. You're going to end up with this all equaling 8 divided by 2 is 4. It's going to come out to be 4. There's an x. There's the e raised to the square root. 4x squared minus 6. All divided by square root 4x squared minus 6. Okay, I kind of rushed at the end, but questions? What you need to do is go back, watch the video that you missed for day 2, study that, and then you just have to start working on the homework problems. If you're having trouble, come see me. I'm here after school. But you can also reference the videos to get help as well.
Can you go over how you simplified it all again?
Yeah, I did that in my head a lot, so I apologize. Are you okay right here? Don't leave on the bell. I'll keep talking. In this piece here, we're using that power rule.
Yeah.
So x is now the g of x. That means you're going to bring down the 2. Write down your g of x. 2 subtract 1. You're left with d of x over dx. That's equal to 1. That's your indication that you're finished. The dx operator is gone now. So I had that. I just put everything together, Nick. So I've got a 2 here. I've got a 4 here. 2 times 4 is 8. But I also have a factor of 2 in the denominator, so that divides to make 4 in the numerator. That's the 4 here. The x, this terrible explanation. The x is right there. I still had the e to the root thing. That's right there. And then I had the root in the bottom. Good question. All right, good job, guys. See you.